Okay, good afternoon. My name is Chris Elam, East Central Service Advisor for GA Larson. I will handle technical service for Rheem, Climate Master, and Mitsubishi, and other brands. If you have a question, feel free to call me on that as well. Today's training is going to be on Rheem heat pumps, the 14, 15, and 16 SEER heat pumps, so the single stage and the two-stage model. So I'll share the screen here and we'll get started. Okay, so we're going to go over some application, some installation components, startup, charging, servicing, and best practices. So periodically I'll check back into the chat to see if we have any questions. And in the chat feature there, I put my name, my direct cell phone number, and my email. So feel free to call me, send me an email if you ever have any question or if I can be of assistance. Okay, so we get started here. Okay, some of this is going to be similar to the air conditioning class that I believe was last week before last. So it is important choosing a location. Excuse me. Refrigerant piping and wiring should always be properly sized and kept as short as possible to avoid capacity losses and increasing costs. Locate the unit where it's not going to be a nuisance, where it won't have us issue with water runoff, like from a gutter or a roof edge. Position the unit away from any drip edges. The units are weatherized, but they can be affected by obviously water or sleet or snow coming down directly on them. Every year we have multiple issues where they freeze. Usually the heat pumps freeze during the off cycle. When they do kick back on, sounds like an out of balance washing machine. We've had them where they've actually broken fan blades before, so do be aware of that. Closely follow the clearance recommendations as well. 24 inches to service panels access. Now that's convenient for the service guys and the installation crew. There's nothing worse than having to sit on top of or lay down on top of the air conditioner, try to work on it upside down, or try to squeeze in between a fence or a house. They do recommend 60 inches clearance above the heat pump to prevent any recirculation. That's what their recommendation is 60 inches to ensure minimal or no recirculation. 6 inches to heat pump grill inlets with a 12-inch minimum recommended. Corrosive environments. This would be not necessarily to our region, but if you're in the coastal regions, obviously salt spray, seacoast areas, that can be an issue. Also chlorine from lawn watering systems. You do not want a sprinkler to directly hit your unit. You will end up with some water spots on them. And if you don't wax it ahead of time or you don't take care of that, it will stain the cabinets. So the coast what to worry about. Shielding provided by a fence or shrubs will give some protection, but you don't want to violate the minimum airflow or service access clearances. Some of that you have little control over. Homeowners will put up fences, put up bushes and such. But if you can, let them know ahead of time. If they do block it off, it will have an effect on their system and its operation. If you do have a unit with space limitations, whether it's a single unit or multiple unit applications, single unit again, 6 inches will reduce clearances below 6 inches will reduce unit capacity and efficiency. Do not reduce the 60 inches on the discharge. And from a service aspect and installation aspect, uh, keep a minimum of 24 inches. If you do have multiple units, which is not uncommon with houses and buildings, when multiple condenser coils are aligned, a 6-inch clearance is recommended for 1.5 and 2-ton models, and a 9-inch clearance in between for 2.5 to 5-ton models. 2 combined clearances below the minimum will reduce capacity and efficiency. Noise considerations, bear in mind this is a heat pump. It does go through a defrost cycle. The Rheems do have kind of a quiet shift compared to some of the other brands. It will stop, allow the compressor to relax, but there is still some noise associated with defrost. So try to keep that away from living, sleeping, or recreational areas. And then to prevent noise transmission, mounting pad for the outdoor unit should not be connected to the structure.
Send him that email
Okay,
also, so he can log in,
yeah,
because I think his has HDMI.
yeah, his does, yeah.
Sorry about that. I had to kick over to mute somebody there. Okay. The mounting pad for the outdoor unit should not be connected to the structure and should be located a sufficient distance above grade to prevent groundwater from entering the unit. Since this is a heat pump situation, elevating the heat pump either on a flat roof or a slab. If you're elevating on a flat roof, which we don't see a whole lot here unless you're doing commercial, use 2 4x4s or equivalent stringers to distribute the weight evenly. Wherever snowfall is anticipated, make sure you raise the unit above the base pad to prevent ice buildup and coil damage. There was another brand a few years ago, horrible drainage out of the bottom of their units. And even if you did raise them up, chances are it was still going to freeze and create leaks in the condenser coil near the bottom. So sometimes if you put them on the ground, they won't really be a problem. Other times I've seen them, you'll kind of grow a whole ice fall up the side of the unit. So it just depends. But if you do raise it up, recommended, some guys use 3-inch pump ups, 6-inch pump ups, get them up, get them up off the pad. Some of the tools required for servicing 410A models. Years ago, when R22 was predominant and 410A was just starting out, everybody had to have 2 sets of gauges, which most people still do. A lot of the gauge sets do multiple refrigerants now if you're dealing with refrigerants. But you do have to have a manifold up to 800 PSIG on the high side, up to 250 PSIG on the low side, a 550 PSI low side retard, manifold hoses, service pressure rating of 800 PSIG. That is important when you're dealing with high pressure refrigerant. If you have old worn out hoses or underrated hoses, they could explode. If you've ever had one explode, it's like a gunshot going off right next to your head. So it is important to check your hoses, check your seals, make sure that they're properly rated. Also make sure you have recovery cylinders of at least 400 PSIG and DOT ratings of an ABA 400 or a BW 400. When you're dealing with direct replacement units, to prevent failure of a new unit, the existing line set must be correctly sized and cleaned or replaced. Care must be exercised that the expansion valve device is not plugged. For new and replacement units, a liquid line dryer must be installed, and it is supplied with each unit, and refrigerant tubing must be properly sized. Recommend to test the old system for any kind of acid If it is positive, a suction line dryer should be installed and removed after about 72 hours. When they talk about line sizing, this is a chart on the 14 SEER single stage models. The screenshot here is 1.5 to 3.5 ton. So you figure out what tonnage you need, and it will tell you based upon that what line sets are acceptable. So you could come over here, 2 ton, 3/8, 5/8, 1/4 inch 5/8. All these are acceptable through here. As you get to the larger tonnage, 3 ton, 3.5 ton, you'll see it's very specific on what is allowed. And if you go over here to this chart here, it'll tell you. So if you're going to do a 3 ton with a very small line set, as you start going into here, you start losing capacity and you start getting into some gray areas. If you have a very long line set, follow these lines up here, 25, 50, 75, 100. If you get over here to the not recommended section of whichever units you're working with, once you get into that, it's kind of all bets are off. It may work fine or it may not work fine. So once you get into this, they do steer you away from, like in this case here, a 3/8, 5/8. You could go up to a 3/8, 3/4. You get a little more into the gray area, but you got some more leeway. And you'll also see right here, for instance, take this one right here, 3/8, 3/4. Like if you're doing under 25 feet, you have a 1.0 correction factor. And if you go all the way over to here, you have a 0.93 correction factor. Still acceptable, but you will lose quite a bit of capacity on that. So if you think you have 36,000 cooling BTUs or heating BTUs, when it's all said and done, by the time you take into consideration your correction factor, because of the length of the line set, you could be at a 31,000, whatever your correction factor comes out to be. So that's another reason why they say keep it as short as possible. It's not always feasible to do so, but if possible, keep it as short as possible. And your interconnecting tubing, so on installation, all units are factory charged for up to 15 feet. Don't take that as the gospel. I got 15 feet, I'm good to go. Depends if it's an upflow, downflow. You could be short, you could be overcharged. It just depends. So a lot of this is just for a gross charge. So adjustment of your charge may be necessary even if the application has exactly 15 feet. So you have other variables such as pressure drop, lift, indoor coil size for different lengths. If it's a quarter inch line, 0.3 ounces per foot additional, 5/16, 0.4, 3/8, 0.6. Approximately 6 ounces for a required factory line dryer. And there again, a lot of this is just if you're going to do a gross charge. You don't want to take your gross charge or the fact that it's 15 feet as being okay. If it's a downflow situation, you may very well be overcharged at 15 feet out of the box. There again, it could be an upflow, 15 feet, and you're still short. So this just gets you definitely within the ballpark, but it's not fine-tuned from there. This goes over some of your interconnecting tubing and fitting losses. So similar to your PVC elbows on 90% furnaces, gives you the different equivalent lengths. So like a 3/8. Let's do 3/4 here. 3/4, 90, and a short elbow, that adds 1 foot 9 inches to your equivalent length. If you do a long radius, 1.3. So by the time you start adding all your fittings in, along with your additional length, That gives you your total equivalent length. Liquid line selection. The purpose of the liquid line is to transport warm, subcooled liquid refrigerant from the outdoor unit to the indoor unit. It is important not to allow the oil to flash any superheated vapor prior to the expansion device. The flashing can occur for a couple reasons. Low refrigerant charge, improperly selected line size, absorption of heat prior to expansion device, excessive vertical rise between the condenser and the evaporator. Also, if you have kinks in your liquid line, that can also cause it to flash prematurely. And then your suction line, the purpose of the suction line is to return the superheated vapor to the condensing unit from the evaporator. Proper suction line sizing is important because it plays an important role in returning oil to the compressor to prevent potential damage to the bearings, valves, and scroll sets. Also, an improperly sized suction line can dramatically reduce capacity and performance of the system. So there's lots of systems that are working and they're cooling, but they're not actually nearly as efficient as they should be. And that's not uncommon. I mean, so you can put the best system in, you can put the best, most efficient system in if you don't follow the proper guidelines, proper line set selections. You could have a 17 SEER system realistically, if you're lucky, getting 13 SEER. And this is a big one too. Long line set applications can require a considerable amount more of refrigerant. The additional refrigerant needs to be managed through the entire ambient operating envelope that the system will go through during its entire life. Off-cycle migration is where the excess refrigerant condenses and migrates to the lowest part of the system. Excessive buildup of the refrigerant at the compressor will result in poor reliability and noisy operation. So if you have a situation with a very long line or a very high lift, if it does not come with a crankcase heater installed, it'd be a good idea to keep a crankcase heater on it. That will keep the refrigerant boil off in your compressor, which will make it easier for starting and prolonged operation. Tubing installation. Observe the following when installing correctly sized L-typing refrigerant tubing. Check the tables for correct line size. If at all possible, you can use, the units will come with specific lines already on them. If you stick to what's there, you're generally safe in most applications. So if you're putting a new line set in, you can check and see, do I have 3/4, 3/8, 3/4, 3/8, 7/8? If you match it up accordingly, that will get you, keep the system running good for you. Always use clean, dehydrated, sealed refrigerant grade tubing. Always keep tubing sealed until tubing is in place and connections are made. I was taught that in school from the get-go from the teacher. And invariably, we used to see guys out in the field. They'll yank the caps off of them and start trying to run them through chases and doing, stuff like that. Invariably, you're going to get something. You're going to get some kind of debris in there. And that debris is going to get stopped somewhere. It could be stopped at a piston, could be stopped at a dryer, could be stopped at your expansion valve, you name it. And it will wreak havoc on you later. So always keep your tubing sealed until you're ready to make connections. The bi-flow dryer is included with each Rheem unit, whether it's an AC or heat pump, and must be installed in the liquid line upon unit installation. Some guys like to install them inside in front of the TXV. Some guys like to install them outside. Part of that's preference, just depends on who you talk to. But the main thing is you want to protect that TXV and keep that dryer to try to absorb any moisture or non-contaminants that are in the system. That's what your dryer is there to protect. When replacing the R22 system with 410A and line set is not replaced, use a flush kit available through Pro Stock. There's different brands that can be used. Whenever you're using the flush kits, make sure you follow it up. Number one, follow the directions, and then follow it up with a bunch of nitrogen. The remaining flush, if you will evaporate. But it is good to use plenty of nitrogen to back that up, to make sure you get any kind of oil traps out of there and any kind of oil that may be stuck to the line. So that helps. If the tubing has been cut, make sure the ends are deburred while holding in a position to prevent chips from falling into the tubing. I've seen guys before, they'll start deburring with the pipe straight up. So naturally all your burrs are going to go straight down inside. There again, that will clog a piston or TXV or dryer or screen. Burrs like that will affect performance dramatically, particularly in small liquid line sizes. For best operation, I came across this a long time ago. Keep tubing as short as possible with a minimum number of elbows or bends. A lot of guys use tubing cutter or tubing benders. Some people are really skilled at it and they make it look, perfectly mechanical. If you can use a bender and make it look nice and mechanical, that's even better. Each mechanical fitting that you have to put in, that's one more joint with the possibility of leaking. So if you can use a bender, outstanding. If the tubing is to be run underground, it must be run in a sealed watertight chase, such as PVC, something somewhat watertight. Use care and routing tubing. Do not kink or twist. That's where a good tubing bender on the vapor line to prevent kinking. Bending a 3/8 or anything below that's pretty easy. 5/8 is so if you're good at it. 3/4, 3/4 or 7/8, I'll always bend it, no matter how kink it, no matter how hard I try. So use a tubing bender if you have one, just to prevent kinks. Now here's a big one. Whenever you're mounting your lines, route the temporary hangers, straighten the tubing, install your permanent hangers. Lines must be adequately supported. If the vapor line comes in contact with walls, ceilings, or flooring, the vibration of the vapor line in the heating mode will result in noise inside the structure. Came across one time where they ran the refrigerant lines under the house. Well, it had vibrated for so long against the water line that it actually fused itself to the water line. So whenever they turn the water on in the house, the same water would actually run through the outdoor unit and the evaporator coil. So it did create a leak, obviously, but it also fused into the water line. So in that case, like there, because they didn't take the proper steps to make sure everything was supported properly and not touching and kinking, it basically destroyed the system. Make sure you blow out the liquid and vapor lines with dry nitrogen before connecting to the outdoor unit and coil. Any debris in the line will end up plugging the expansion device. TXVs tend to have enough problems on their own. We don't need to create more problems with additional debris that will get in there and end up plugging it up. Now, there's different ways that you can attach to the line. Some guys use the Pro Press. They even have shark bite fittings now that you can shark bite your refrigerant lines. I haven't used any yet. Most people braze them. So it is imperative that you purge with nitrogen as you're brazing, because as you're brazing all the black scale, you see on the outside as you're brazing, all that gray and black burnt uh, carbon there. What you see on the outside is also what you get on the inside, unless you purge with nitrogen. Uh, you be sure to both make sure both valves are shut off. Remove your service caps and your cores to protect the seals. Once you've done that, be sure to wrap the valves. I would do both. Wrap the valves with a wet rag and then also use a thermal barrier, whatever kind you like, the paste or the gel. Um, the more you can protect these valves, the better. If you overheat them, if you don't take the right precautions, they will leak. I've seen that a few times last summer. So take the extra, 30 seconds, whatever it takes to protect your valves. 5 minutes spent time on the installation could save you hours on callbacks. Braze the tubing between the outdoor unit and the indoor coil. Flow dry nitrogen into the pressure port. After your brazing, use appropriate heat sink to cool the joint. Reinstall your Trader core into both pressure ports. And do not allow your vapor line and liquid line to be in contact with each other. That can cause undesirable heat transfer, resulting in capacity loss and increased power consumption. Because all the new units we're selling today, everything's being sold on efficiency, let's face it. So if you're going to sell on efficiency, do everything you can to give them what they're paying for. Customers don't know any better, but if you do a really, really poor job and their new 16 SEER doesn't save them any more money than their old 12 SEER did, they're not going to see any benefit. Leak testing. This is huge. I mean, I still see guys, they'll braze their joints in, put a vacuum pump on it. They don't even bother to leak test it. The indoor coils do have a holding charge of dry nitrogen. So once you pop those out, you should get a small puff of nitrogen. This is pressurized line set and coil through service fittings. They set 150 psi G maximum. I personally always test it higher than that if I'm just testing my line set and coil. Once you're pressure testing your compressor as well, you do want to keep that about 150. But pressure test that, let that sit for at least 15 minutes. Make sure it hasn't dropped. If it has dropped, use some soap bubbles, figure out where your leak is. Then we'll get into the control wiring, low voltage wiring. It's 24 volt. Need a 40 VA minimum transformer. Most furnaces and circuits, air handlers will be sufficient for that. Do use 24 volt, 18 gauge wire. Don't use speaker wire or that really thin thermostat wire. It just doesn't work. It creates more trouble than it's worth. Always run extra wires. If you're running an air conditioner, I ran at least a 4-wire if I needed a 2-wire, and I always ran an 8 if I needed to. That way down the road, if you need to switch a wire or two, wire is not horribly expensive. There again, that could save you a lot of money down the road as well. Now the 14 SEER, 15 and 16 SEER 2-stage, all these are non-communicating units. They can be used with communicating furnaces with the EcoNet thermostat. So you have that option as well, but typically you're going to use either a single-stage heat pump stat with auxiliary heat or 2-stage if you're doing a 2-stage heat pump, 2-stage air handler. Your power wiring, it is important that proper electrical power from the commercial utility is available at the unit. Voltage ranges from below minimum 187 to a max of 253. if you're down at 187 or even 190, you're probably not, your compressor's probably not going to start. And if you're up over 253, you're probably going to end up having compressor and fan motor damage. So, but you've got single phase 208-230, three phase 208-230, 460, and 575. Always install a branch circuit disconnect within the side of the unit. That should be code at least pretty much everywhere. Power wiring must be ran in a rain-tight conduit. There again, you're dealing with a 208-230 circuit below the access cover at the bottom of the control box. Connect the power wiring to the line voltage lugs on the contactor. And then you also have a factory grounding plate right here. Now it is important, check all electrical connections. That includes factory connections within the unit. Don't take for granted that it comes from the factory and everything's good. While you're down there, you're making your connections, go ahead and double check all four lugs. With a different brand, we had a whole run of them where the contactor, the top two, were not tight for whatever reason. So it doesn't take long to burn up a contactor if you have a loose wire there. So always check those. Now, as you're looking at the units, this is a model number explanation or nomenclature. So your first letter, in this case here, Rheem will be an R. Your second letter is going to be a P for heat pump. Your third, which will be your 2 digits, is going to be your SEER. So we're dealing with 14, 15, or 16 SEER. The next 2 digits are your tonnage. So we've got 18 through 60. The next letter will be your, basically your design version. In this case here, A, B, or F. We typically stock the F because we get better ratings out of the AHRI matches with the F model. And then the next letter is going to be your voltage. Your J is going to be your most common. That's your single phase 208-230. We do have them in C voltage, 3 phase 208-230, and D, which is 3 phase 460. Your next number, in this case here, is 1, will be a single stage. If you have a 2, it's going to be a 2-stage. Your next letter is going to be an N, and these particular units are non-communicating. So you have the N, and then the A is your minor series. So as they make revisions and make improvements, that could go to a B, C, D, whatever minor series changes are made. Component overview here. This is a picture of the 14 SEERs heat pumps. Downward view here, fan blade, and things I like about the Rheem. You can access these coils real simply with 1 or 3 screws, depending on the tonnage. They're all single row coils, easy to clean. There should be no reason that these coils do not get cleaned and cleaned properly and cleaned thoroughly, because they're single row, you can see right through them. Down here, you've got your easy access to your service valves, and you got 2 nice little cups here on each side to put your service valve caps and the Schrader cores and such. To 16 SEER 2-stage unit, predominantly the same unit. We utilize the same defrost board. Compressor obviously is 2-stage. So we'll get into the defrost board. This is what you're going to see typically on the single stage and 2-stage. These are ever evolving. They've probably had 4 or 5 revisions since I've been here. Some of the terminations on Rheem, obviously the reversing valve is different. People ask how to wire one up. So it's fairly simple once you understand it. You have your C, which obviously is your common, your R, which is your 24-volt hot, your Y, which is your uh, compressor contactor, first stage of heat, or first stage of cooling, or first stage of heat. You have your B terminal. So when you think B, in some brands, B can be common, but with B, with Rheem, uh, think of O and B. Every thermostat you set up, you've got to say, is it an O or a B? B is your reversing valve, so it's going to engage in heating, which is opposite of the O. So your B is going to be your heat, and then your D will be your auxiliary heat. So once you go into defrost, you're going to immediately get a signal in your D wire, which is going to turn on your auxiliary heat. Now, some of the features on these are a demand defrost board. There's some other brands that also operate on a demand defrost. That or other ones operate on like a time and temperature. So this control will monitor the outdoor coil and the outdoor air temperatures during the heat mode operation. If the temperature of the coil is colder than the defrost control initiation temperature calculation, the control command will perform a defrost cycle. All calls for cooling and heating are received at the defrost board. A few important features include a built-in time delay, diagnostic capability, function setup, defrost termination adjustments. And also, if you come up to a unit and you don't see LEDs, that's an indication that your R signal is not there. Now, in most cases, if you take the R signal away, you can still cool and you can still do your first stage of heat. The thing is, if your R signal is not there, your board is not powered, so therefore the logic hasn't kicked in yet, so it will never defrost. So always take a look at that. Make sure your LEDs are there. That holds true of train. Pretty much any defrost board that has LEDs. If you don't have LEDs, it will never defrost. So we've got our different connections over here, our low voltage, YBDRC. We have our two test pins right here. That's important, which we'll get into their functions here in a second. We have our diagnostic LEDs. Pay attention to what they're doing because they are blinking. If it's a trouble code, they're blinking a very specific code at you. Do make sure that you know which LED is 1 and 2. Guys sometimes cross those up, and that creates more problems. You also have your outdoor ambient temperature and your coil temperature. Your dip switches, that's going to change your defrost termination temperature. Coil and reversing valve terminals, low pressure, high pressure, Y and CC out, and your two fan terminals. So here are your LEDs. So it's important, and they do say LED 1, LED 2 just beneath them or above them, depends on how it's situated. If they're off, you have no 24-volt power there. If they're both on, solid, coil sensor failure. LED 1 off, LED 2 on, you have an ambient sensor failure. Flash, normal. LED 1 off, 2 flash, low pressure lockout. Flash LED 1, off LED 2, high pressure. And on 1, flash 2 gives you a low pressure control open. Flash 1, on 2, high pressure control open. And then you have your alternating flash, which means you're in 5-minute delay. So your defrost cycle process, you can't jump these sensors out. They're 10K ohm resistors, so they're looking for temperature to differentiate what they are. So if you jump them out, it's not going to really do anything. So there's 3 things that are required to initiate a defrost. Now you can walk up at any time it's in heating and hit, and all you got to do is short them out. Don't leave your jumper on there solid. Just all you got to do is touch them, and it should immediately go into defrost. But if you're looking for a normal operation, a normal defrost to take place, the outdoor temperature must be below 35, and the compressor must have operated for at least 34 minutes with the outdoor temperature below 35. And then the difference between the outdoor air and the outdoor coil must exceed the calculated difference. So it's got to satisfy those three things uh, to do a normal defrost. Now, like I said, there again, you can test your defrost board just by shorting your test pins, and it may go into defrost for 30 seconds. It may go into defrost for 3 minutes, but as long as it goes into defrost, your board is at least functional. Defrost termination cycle will continue. The maximum is 14 minutes of time, or the outdoor coil has reached the termination temperature that is selected on the dip switches. The factory setting is 70 degrees, and for the most part, that is fine. But it can be changed to 50, 60, or 80. We've changed a couple of them to 80 before, so it gives them a little longer defrost. Once termination takes place, this is what I call the quiet shift or soft shutdown. The system will shut the compressor off for a 30-second time delay, and then we'll re-energize the reversing valve to put the system back into heat mode. Once the time delay expires, the compressor will re-energize. The time delay periods are necessary to reduce the amount of noise. There's still a certain amount of noise associated with your defrost, but that does limit that, or tries to limit it. Your test pins. So your test mode pins have three very useful functions. Nobody likes to wait time delays. It's a pain in the butt to wait 5 minutes. So if you're in a time delay on the outdoor unit, all you got to do is short your test pins out, and it will immediately kick in your unit. So that works for both heating and cooling. So no sense in waiting the 5 minutes out. If you come up on a unit that's been locked out due to high pressure or low pressure, the only way to reset that lockout is to break your 24 volts to the outdoor unit, or you can short the test pins and that'll reset your lockout. And you can also initiate a defrost anytime it's in heat mode. So like I say, that can be a quick 30-second defrost, or it can be, whatever it needs to be. Let's see here. Okay, now we get into the defrost sensors here. The defrost sensors, they're both 10K ohm resistors. One sensing your outdoor ambient, the other one sensing your coil temperature. We had some issues not too long ago with some sensors where they weren't reading correctly for whatever reason. So if an ambient sensor fails completely, it's supposed to initiate a defrost every 34 minutes. But a lot of times, if you go back to here, you'll see if you lost a coil sensor completely and it recognizes that, it will give you a code. If you lose an ambient sensor failure completely, it'll give you a code. It may not be a complete failure. It just may not be sensing the correct resistance. So if your sensors are out of calibration, the system will not perform a proper defrost or may not enter a defrost. So these are negative coefficient 10K ohm resistors. So the easiest way to do that is to get a known temperature. Obviously, a cup of ice water works best. So you can say 32 degrees. Here's your 10K ohm chart. And I can't go all the way down to 32, but we'll just go to 40. We'll go to 37 degrees. So if we have a 37 degree known temperature and a 10K ohm chart, our resistance should be 28,365. So if it's way higher than that, obviously there's a problem, or if it's way lower than that, it's a problem. So based upon that, we should be right around this temperature here. And it's real obvious, especially if you put it in ice water, or if you know exactly what the temperature of the line is with a pipe clamp, you could do that as well. If both sensors are calibrated properly, your sensors are fine. Let's see here. So your ambient sensor is actually mounted just below your electrical panel right here. Yeah, right here is their little chart here. So we'll say 32 degrees on this one. We should have had 32,650. That's what we're looking for if you're doing like an ice water test. And then the defrost coil sensor is really hidden. You won't typically see the wiring because the way it's secured so the fan doesn't hit it. But if you're looking at the electrical compartment, or if you take the top off the unit, it'll be to your left side at the very top of this coil right here. And you'll see this line here is too small for the bracket. This line here is too small. This line here would work, but they want you to put that at the very top bracket right here. And the voltage output from the control board to the sensors, it's a 4.5 to 5 volts DC. So if you have a completely failed or shorted sensor, it would recognize that. It cannot recognize if the sensor is not calibrated properly. So that's where sometimes you have to calibrate it or make sure that they are calibrated. These also have high pressure cutouts. It's an auto reset that opens at 610 psig, and it closes at approximately 420 psig. So if you're hitting 610 pounds, you know obviously there's a restriction somewhere. If this control opens 3 times within a call for heating or cooling, then you will get a lockout. And it will remain locked out until either the 24 volts to the unit is disrupted, or until you hit the test pins. Some common charges of high pressure switch lockout include overcharged systems, inoperable fan motor, dirty outdoor coil. So it's not uncommon, for instance, if you put a downflow system in, because we'll get into the charging charts, they are different on heat pumps between upflow and downflow. If you put a downflow heat pump in and it's 10 feet from the outdoor unit to the air handler, real good chance it's going to be overcharged out of the gate. So if you actually start the unit and kind of watch it, you'll see your head pressure start to climb. Okay. Get your low pressure cutout. Your low pressure is an auto reset as well. It opens up at 15 psig and recloses at 40. Let's see here. The control board will respond differently depending on whether it's heating or cooling. Cooling mode: if the switch opens during cooling, the outdoor unit will stop. Compressor and the outdoor fan motor. If the control resets, the system will restart after a long time delay period. There again, if you get the same 3 trips and a call for cooling, it's going to lock it out. In heating mode, if the low pressure control opens during a call for heating, the outdoor unit compressor and fan motor shuts off, and when the switch resets, the system will enter a time delay and then restart. There again, it will also lock out after 3 times, which will be real evident in heating season, well, both cooling and heating. In heating season, if it locks out during a period of time, their electric bill is going to go up substantially. the Copeland ZP compressors, scroll compressors that are in all these units. They're designed to deliver a 2 to 4% increase of efficiency over the the prior generations. There's 3 single and 3-phase configurations. You have 3 windings: your run, which is going to be your red, your start, your purple, and your common, which is going to be your black. Your orange wire connects the run wiring to the common terminal and capacitor. If you cross these up, if you're replacing a new compressor, or somebody's been messing with it, or if it's not wired right from the factory, hypothetically, you will get what appears to be a lock rotor situation. It'll try to start, it'll drop out. So if you ever come across that, put a new compressor in, first thing you want to do is double check everything, double check your wiring. Make sure your red's going to your run, your purple's going to your Rheem, your black's going to your common. Make sure that's the way it is at the compressor, and also at the contactor. And then make sure your orange wire is connected to the appropriate terminal on the run capacitor. We get that quite a few times a year. The ZP compressors have internal motor overload protection. It'll open the common connection on a single phase and the center on the Y connection on a 3-phase. You'll notice this because you'll have 2 open windings. Your compressor will not start. It will not draw power, and if you start ohming out your compressor windings, you'll find that you have 2 open out of the 3. If you go a step further, touch the compressor, it's probably going to be really, really hot. Crankcase heat, they are important. They do keep all that excess refrigerant, your liquid refrigerant, boiled out of your crankcase, which makes for easy starting and increased longevity. When you're doing a vacuum, internal low vacuum protection, the unit will stop pumping. It will stop unloading when that pressure ratio exceeds 10 to 1. So sometimes they can be troublesome trying to pump them down. Net compressors should never be used to evacuate a refrigeration or air conditioning system. Field pressure testing for leaks. When pressure testing an outdoor unit with nitrogen, it is recommended to test with the compressor, certainly at 150 psig. I've tested them much higher in the past myself, but the possibility is there because you're dealing with that compressor, such a tight space. If you get too much pressure in there, they can actually explode. You have your circuit breaker trips. This is important too. If line voltage protection device fuse circuit breaker is open, don't just keep resetting the breakers. I've seen guys do that. You can eventually do damage to your breaker and or your panel. And if you continue to do that, the compressor could basically vent a motor terminal pin. If you haven't come across one of those before, I had one actually do it right in front of me once. It's called a terminal vent. One of your 3 terminals on your compressor will be blown out. When it blows out, all your refrigerant goes out as well. If it happens and you're right there, you could get hurt. So if it's tripped and you reset it and it trips again, stop right there, go to the unit, figure out what's shorted there because you have a direct short somewhere. Whenever you have to remove a compressor from the outdoor unit, this is any compressor, never use a torch to remove the compressor. The guy that trained me years ago, he thought it was real funny to have everybody use the torches to unbraze a compressor, and every once in a while you'd get a big flash of flame out of there on the oil. It would keep burning. I prefer to cut them out. That's how I've done them. It is recommended to cut them out. That way you don't get any kind of fires or any kind of contaminants or any kind of oil fires. Because you can get a pretty good flash of oil flying out of there. Startup or replacement of a new or replacement compressor. When charging a system with a scroll compressor, charge liquid into the high side only. It's not a good practice to dump liquid from a refrigerant cylinder into the crankcase of a stationary compressor. If additional charge is required, charge liquid to the low side of the compressor when the compressor is operating. Do not start a compressor while in a deep vacuum. Internal arcing could occur. And do not operate compressor without enough charge to maintain at least 55 psig. A little further here, do not operate with a restricted suction or liquid line. Do not operate with a low pressure cutout disabled. Allowing suction pressure to drop below 55 for more than a few seconds could, over time, and overheat the scrolls and cause early drive bearing damage. Now your 16 SEER models use the two-stage compressors. These compressors have an internal low voltage unloading solenoid that will control the hot gas bypass ports inside the scroll assembly. When operating in low stage, the bypass ports open to reduce the compressor capacity to approximately 67%. When a call for second stage takes place, the Y2 will energize the plug on the unloader solenoid. The plug contains a bridge rectifier that takes 24 volts AC, converts it to a DC voltage of 15 to 27 volts DC, and that will now energize that solenoid. There's an approximate 25% increase in compressor amps when the compressor goes to second stage. Usually you can hear it kick in. You should also see your pressures on your gauges change. Also your amp draw would change as well. That's important to understand. Yeah, here's, so the nitrogen pressure testing safety limit. Suction line dumps the refrigerant suction gas directly into the shell of the compressor. The suction gas acts as a coolant for the compressor motor. The most pressure the compressor shell will be exposed to is the suction line pressure or the pressure during off-cycle equalization. If the compressor is pressurized to abnormally high pressure from nitrogen testing, the compressor can, apparently it's happened, has exploded. They can explode. And obviously serious injury or death could occur. So if you're taking your compressor into the equation, when leak testing with nitrogen, the pressure on the outdoor unit should be limited to 150 psig. Some of the pumping problems here. There are many misunderstood facts regarding compressor pressures. High suction pressure and low condensing or head pressure, that will achieve peak performance. As the suction pressure drops and the condensing pressure, head pressure rises, your actual system capacity goes down. Scroll compressors do not have valves. There is no valve test as with the reciprocating. When you first start a scroll compressor, the suction pressure should fall and the condensing or head pressure should rise. If this happens, you know the compressor is pumping. If a compressor is operating with an excessive vibration, metallic sounding operation, or higher than normal amp draw, your compressor may have internal damage. That's usually not very hard to hear. I'm sure most of you guys have heard a noisy scroll. If the scroll plate breaks, it will make a heck of a racket. So if you hear that, you don't let it run too long. Just turn it down. and resolve the issue. A lot of the units will come with a crankcase heater already installed. Most installations will require the installation to prevent excessive liquid buildup or migration in the off-cycle periods. Generally speaking, starting kits are usually not needed because the scroll components always start unloaded. So even when the pressures are not balanced, they'll still start unloaded. Those of you guys that have Meg-ohm testers, Megger testing of a scroll compressor can result in an invalid reading due to the position of your scroll compressor in the motor oil. They have those little, I think, I won't say who, but there's a brand that makes them. It's got a little chart, good or bad, on your Meg-ohm reader. If you line up 10 brand new scrolls, I guarantee you at least 9 of them will show as being defective. So Meg-ohm testing of a scroll compressor doesn't give you a real good reading because of the position of the scroll compressor in the motor oil. Center bearing wear at the bottom of the compressor can be excessive when liquid floodback or liquid flooding starting occurs. The bearing wear can lead to rotor drag on the windings and also to a direct short. So if you ever have an opportunity to see one cut open, you can see where the oil line should be and where the oil line, a flooded compressor or a severely overcharged unit, you can see where the oil line is and you can see the damage that begins to occur. Jumping out a low pressure switch on a 2-stage scroll can cause the second stage solenoid inside the compressor to fail if the Y signal is applied to the unloader plugs. Okay, I'll tell you what, it's 5:02 now. Let's take like a 10-minute break and we'll start back at 5:12. So we'll take a few minutes here. Okay, it's 5:12, so we'll go ahead and get started again here so we can get you guys out for the evening. Okay, another component is compressor contactor. These are 24 volt. Generally, they're going to be single pole contactors. When 24 volts is applied to the contactor solenoid, the contactor will close, therefore passing the line voltage across that contactor. If the contactor fails, it must be replaced with one of identical electrical specifications. Occasionally you'll run into a shorted contactor. So if you're out on a system and you've got a heat pump that's got a short, a lot of times the contactors, they don't happen often. When they do, they always seem to be a pain in the butt to troubleshoot, to find. So normally what I'll do is I'll go out there and pull one wire off the contactor. If the short's there, then I can pick that up real quickly. Rule that out quickly off the bat. Doesn't happen, but there's usually 1 or 2 each year. And I always seem to kind of go past that and spend a lot of time looking for something that didn't really need to. You'll have your run capacitor. Your single speed models will feature dual run capacitors that serve the compressor and the outdoor fan motors. The 2-speed models will use an ECM outdoor fan motor. So the run capacitor in these models will be a single type dedicated just to the compressor circuit. You have your outdoor fan motor and fan blade assembly. The 14 SEER and 15 SEER are going to have a PSC outdoor fan motor. So that's 1 speed for both cooling and heating. The motor is disconnected or is connected to the dual run capacitor at the capacitor labeled fan. The motor is energized by the defrost control board terminals labeled fan. So you'll have two fan terminals on your defrost board. Uh, One wire is always hot coming off your contactor, and then that is made or broken uh, by the defrost cycle. So if it's in normal operation, that's going to be a hot terminal. If you go into defrost, it will disable that fan terminal. And that's another good one too. Had a guy call the other day. His outdoor fan wouldn't come on, so he was checking. He thought it was a bad motor. We got to talking, walked him through it. Now he checked basically that he had 240 between the common and the hot fan terminal. When he switched over to the other fan terminal, he did not have 230, so therefore his motor was not being engaged. So ultimately, the motor was fine, and the defrost board was the faulty component. 16 SEER, your 2-speed ECM outdoor fan motors. The motor has connections for line voltage, which are always hot, and then 2-wire connections for low voltage. The defrost control board connection is the yellow low voltage wire that receives 24 volts on a call for first stage. The Y wire, during both heating and cooling modes, the outdoor fan motor will have 24 volts applied to the motor, and the motor will run in first stage. When a call for second stage occurs, the Y2 signal from the thermostat will place 24 volts on the white wire connected to the outdoor fan motor. That's where I said earlier, use the same boards. That's where that comes into play. So your white wire will also feed your fan motor as well as your second stage solenoid on the compressor. So when the white wire receives 24 volts, the outdoor fan motor then goes to second stage or high speed. When the call for Y2 ends, that call on the white wire drops out, you're back in Y1. And you'll also see what looks to be a filter dryer on the inside of these units. It's actually a muffler. Compressor mufflers are used to reduce both low and high frequency gas pulsations. The mufflers are mounted on the discharge line at the outlet of the compressor prior to the reversing valves. Mufflers should be changed or flushed if a compressor burnout has occurred. If you ever look inside of a unit, you'll see all units are different, but you'll see the piping, how it kind of goes through different turns. It's never like a direct path. The reason for the different turns and the lengths, in this case here, the muffler as well, is to reduce frequency noises. If you ran straight piping to the closest direct lines, these units would get loud, much louder. The frequency gas pulsations would be, in some cases, pretty severe. So that's one reason why the muffler's there. It's basically a hollowed out filter dryer, more or less, but it's used to reduce sound. You also have your reversing valve. Now here's where it kind of gets good. So your reversing valve, your 24 volt operated valve that directs the changes of direction of the refrigerant flow. In cooling mode, that valve will direct hot gas to the outdoor coil. In heating mode, the valve will direct hot gas to the indoor coil. So you have 4 piping connections. The bottom or single pipe is always the hot gas discharge from the compressor. The middle tube on top is always the suction gas connection to the compressor. The left-hand connection, in this case, goes to the outdoor coil, and the right-hand piping goes to the indoor coil. That reversing valve will direct the discharge gas either to the left or to the right. So depending on what brand you're working on, that could be reversed. Some of them I've seen upside down. But energized by the low voltage B wire in heating mode, the B wire will place 24 volts on the solenoid to direct the gas to the indoor coil. In cooling mode, that solenoid is not energized, and it will direct the hot gas to the outdoor coil. So it shifts the flow via an internal slide. These are kind of descriptive pictures here. So that slide assembly will move left and move right. The direction of the slide movement from left to right is controlled by hot gas capillary tubes that are mounted to each side of the reversing valve. These little tiny lines you see right here, not a real good picture, but those two little tiny lines you see on each side, that helps push the slide to one way or the other. When energized, the capillary will direct hot gas to the right side of the valve, and the hot gas will now be directed to the right side piping leading to the indoor coil. A small temperature rise between suction gas into the valve and out of the valve is completely normal, a very slight rise. Now, a couple things in order for a reversing valve to switch. One, you have to have a solenoid that's energized or de-energized, either way. You also have to have a working compressor. And then you have to have functioning capillary tubes to help the switch back and forth. So if you don't have a working compressor, if you engage or disengage the reversing valve, all you're going to do is hear a click on the solenoid. And if by chance you have when you name it, a kinked, cut, whatever, capillary tube here, it will not switch one way or the other like that. So if a reversing valve fails to shift the internal slide to the proper position, the problem can be no voltage of the solenoid, a failed solenoid, or a stuck internal slide. So it's easy to test to see if you have 24 volts to the solenoid. If you hear the solenoid click, you can engage and disengage. If you hear it click and disengage, your solenoid is working. Occasionally, you can end up with some stuck internal slides. You can also prove this by I got some of them on Amazon. They're little tiny rare earth neodymium magnets. If you put that on a reversing valve, you can actually watch the slide. Now, you'll see how large the reversing valve is. The slide is nowhere near that big. The slide is actually pretty small. So if you take your magnet, you can find each edge of your slide with a magnet. And if you put it on there, you can actually watch it move back and forth, if it's engaging and sliding properly. So if you're going to test the reversing valve, check for 24 volts between RV and C. If there's no voltage present, replace the defrost board. If the voltage is present, go to the next step. Remove power to the outdoor unit, disconnect the two wires from the RV and C terminals, and check the resistance of your solenoid. Resistance should be measured. If infinite resistance is measured, the solenoid is open. Replace the defective solenoid. If the solenoid checks out good, if the valve will not shift, the reversing valve may be defective. Also make sure there is sufficient refrigerant in the system, and also you have a working compressor. So if you're questioning shifting problems, I had one guy, not last summer, summer before last. He actually cut the valve out and actually cut it in half, just so we can get a good look at it. There was so much gunk and nasty stuff inside that even when you cut that open, you really couldn't hardly get it to slide back and forth. So you can get stuff in there that will lodge them one place or the other. Usually won't run into too many of these, but they can be a problem to check. But it's easy enough to check. So as you're checking here, you'll have your 4 lines. In this case here, you run the system in cooling or heating. Locate the common suction line that runs from the reversing valve to the compressor. So that's going to be your middle line here. Locate the suction line coming from the indoor coil. So if it's in cooling mode or outdoor coil heating mode, measure the temperature of the suction line within 3 degrees. So don't 3 inches. Don't measure way down here. Try to get as far as you can up through here. They're using a touch type probe, but you can use a pipe clamp. So try to get away from the body so you're not getting any temperature bleed through. The temperature of the common suction should be no more than 10 degrees warmer than the suction line coming from the evaporator cycle. If the temperature is above 10 degrees Fahrenheit, the reversing valve is defective, because you should have basically two distinct temperatures. Your discharge, your single pipe at the bottom, is going to be hot. One of these, either left or right, should be equally as hot within a degree or so. Your center will be cool or hot, and then the other one should almost match what that one is. So if you have wildly different temperatures on all 4, then you're probably bleeding through. But they're saying 10 degrees between, in this case here, these 2 here, or if you're in the different reverse cycle, these 2 here. If you have that, then you want to replace that valve. You also have, in some of these models, what looks like another filter dryer. It's called a charge compensator tank. Refrigerant storage tanks that are used in heat pump systems to compensate for charge imbalances between heating and cooling. You'll have 2 vapor lines and 1 liquid line. The tank is brazed into the vapor line and is connected via a T to the liquid line. When the heat pump is operating, the tank is at the same temperature as the vapor line. When the system is in cooling mode, the vapor line is acting as a suction line and the tank is cold. When it's in heating mode, the tank will be hot. So you'll see the gray one here is a muffler, and this one here is your charge compensator tank. You have your outdoor coil. They're copper tube and aluminum fin. The coils feature parallel hot gas circuits that feed into a subcooling loop. Hot gas enters the condenser coil, distributes equally to parallel circuits. The hot gas is reduced to condensing temperatures, and the refrigerant condenses to a mixture of liquid and gas. The liquid and vapor mixture then travel through the subcooling loop, where the refrigerant is cooled below the condensing temperature. Once that refrigerant is cooled below a condensing temperature, the refrigerant enters a liquid state. The refrigerant leaves should be subcooled approximately 10 degrees. Now, like I say, one nice feature about these coils, they are single row coils. Easy to access, easy to clean. That means everything. My coil at my house is a double row coil. Very efficient system, but it's a double row coil. So every time I want to get a real good clean, I have to get in there and separate the coils and clean them, which is a pain in the butt. So nice single rows, easy to access coils. So there's never really any excuse for them to be dirty or unserviced properly. You also have your outdoor TXV. All the ones we stock, there are some cheap models, builder grade models that have pistons. We don't stock them. So all the ones we stock, all the outdoor units will have TXVs. Currently, they are braze on. In the next revision, they'll be bolt on, which will be beneficial if you have to replace them. All heat pump models use a TXV device in the outdoor units. TXV has an internal check valve that allows the refrigerant liquid to bypass when it's in cooling mode. The valve is designed to maintain around 10 degrees suction vapor superheat during heating mode operation. These valves are not adjustable. They also have your liquid and suction valves. Now, what I like about them is they're real easy to get to. You have plenty of room to service on. You also have that little trap door behind that there, so 2 screws. You can take that trap panel away, and you can actually reach in and start checking components without having to take the top off. Sometimes it's a little bit of a stretch, but when I'm on job sites, I mean, I do it all the time. So the unit is equipped with factory installed service valves. The valves are opened using a 3/16 liquid line and a 5/16 suction line hex wrench. When brazing line sets, the valve should be protected. I can't stress that enough. I know years ago I had one of my service guys or install guys, and magically all his units, they all had leaky service valves when he'd do installations. Mine never had leaks, but then again I took the time to wrap them. So I was out there one day, I actually saw what he was doing. Well, that's why he had leaky valves all the time. He didn't take the time. He figured he could braze it quick enough, and therefore he didn't need to wrap them. But that's not the case. Make sure that you wet rag them, and then use some kind of a cooling gel. So a few issues with your outdoor TXVs. Every year this is going to pop up hot and heavy here shortly since it's getting warm. The outdoor unit's expansion valve. If there's a problem with the valve, it is generally going to be related to the internal check valve or the valve's ability to properly meter refrigerant. If you get something stuck in there, if your sensing bulb loses charge, different things, it can be slammed shut. Your internal check valve could be stuck, could be blocked. So internal check valve problems in cooling mode, liquid refrigerant exits the outdoor coil and enters the expansion valve. The liquid should exit the valve without any pressure drop. So there should be almost no pressure drop across that internal TXV because it's bypassing. If it is restricted, the liquid would experience a pressure drop across that valve. The pressure drop will cause a drop in temperature of the refrigerant as it exits the valve. So a lot of times if that happens, by the time it does get to the indoor TXV, it's already started to meter, and therefore it won't cool properly. In heating mode, a stuck open check valve would allow refrigerant to bypass the metering device and enter the coil unmetered. The system's pressures would be high on the suction and low on the high side. So that could also be a symptom of a bad or a stuck reversing valve. If you're having metering problems metering the TXV related to debris becoming trapped in the TXVs or the sensing bulb that leaks the TXV charge. In either scenario, the heating cycle will operate with a restricted refrigerant flow. When that flow is restricted, the outdoor coil will usually freeze and the compressor will overheat. A few years ago, the particular brand we were selling and installing, every time we put a new coil or air handler in them, you'd almost cross your fingers and hope that the TXV worked properly. They've gotten a lot better, but as your installation practices improve and just an extra 25 minutes on a job with such as flushing properly, wet ragging your valves, protecting your surface valves when you're brazing, protecting your TXV when you're brazing, putting on filter dryers. All those little things don't take long, but that can save you hours and in some cases thousands of dollars on callbacks. So if you're going to check, this shows how to check your TXV. You have some kind of they're using a touch probe here, but you can also use a pipe clamp. Um, so you're basically going to check on one side. In this case here, you're going to measure the temperature of the liquid as it enters the TXV, and it should also be the same on the outside there. So if you're checking at the top, the outlet, and then the inlet, there should be no difference in the two as it passes through the TXV. If you do see a major difference there, then you know there's an issue with the bypass. Same with heat mode. If you're checking here, your inlet. If you're checking your outlet, you compare the two temperatures, there should be a significant difference as it passes through the TXV. The temperature of the tubing leaving the expansion valve should be much colder than the outdoor temperature. If the temperature of the tubing leaving the TXV is warmer or equal to the outdoor temperature, the compressor, reversing valve are functioning properly. Replace the TXV. So also your TXV tests, you can do what I call exercise in the TXV. You can use hot water or cold water to open and close your TXV. So in this case here, you're going to run it in heating mode, measure the suction pressure, and calculate the vapor superheat. Should be around 10. So with the unit running, remove the TXV from the suction line and place it in a glass of ice water. At that point, your suction pressure should drop dramatically and your suction vapor superheat should rise. If that valve does not respond with pressure and superheat change, replace the TXV. And you can do the same thing if you put it in hot water. So if you put it in hot water, then cold water and back, I call it exercise. And sometimes you can force them to open all the way and close all the way. But if you don't get any kind of response, replace the TXV. You also have a factory supplied filter dryer. They are Emerson Biflow BFK 3H dryers. The dryer should be installed in the liquid line. Installing the liquid and dryer at the coolest possible location will ensure the dryer has the maximum ability to hold water. The dryer should be changed with an exact replacement if the circuit is opened for servicing. Matching indoor coils. In order to get an AHRI match, it has to be matched up with a matched air handler or a matched coil. So when properly matching, the outdoor and indoor have the proper heat transfer capacity for the system refrigerant. If they're not properly matched, abnormal heat transfer, coil volume can cause pressure switch issues, low system capacity, early system failure. We've had a few where they've used aftermarket coils, and in theory they're okay, but they happen to match them up with a particular brand coil, and that coil comes with an AC only TXV. So you can imagine what happens when it goes into heat. It immediately hits high pressure within 10-12 seconds. So if you're going to use an aftermarket coil, you do want to make sure that it's an AHRI match, and you also make sure you have the proper heat pump TXV. Diagnosing plugged liquid lines, that's pretty simple. Put your pipe clamp on each side of the dryer as you're checking as it's running. Check each side, let it stabilize. So if you start getting a temperature difference, higher than 2 degrees, you probably have a restriction in there. I've seen them as high as 9 degrees before. So if it's that high, you know you're creating a restriction right there. Now you can actually measure the heating capacity of an outdoor unit. Uh, Pretty straightforward. You don't need any electrical backup. The formula to calculate this is your heating BTU output equals your indoor air CFM times your uh, sensible heat standard times your dry bulb temperature rise across the indoor coil. So the process for this is operate the air handler furnace, indoor fan, and perform an air volume circulation. Record the CFM. Measure the temperature of the supply air at the supply plenum. When the supply air temperature stabilizes, record the temperature of the supply air, subtract the return air temperature from the supply air to determine the dry bulb temperature rise. Then determine your sensible heat constant. And in our case here, we're about sea level, so 1.08. So if you apply that, we're going to do an indoor CFM of 1,000 CFM. Sensible heat constant's 1.8. Return air 70. Supply air 95. Temperature rise of 25. So if we calculate that out, this system's operating at 27,000 BTUs. So if we have a 36,000 BTU unit, this will be underperforming quite a bit. And then some optional equipment. Some units come with compressor start kits, which will give you a potential relay as well as a hard start capacitor. Some other options are your crankcase heaters. Some will come with them. Some are optional. And then all heaters should be placed down here towards the bottom. Its purpose is to drive refrigerant from the compressor shell during long off cycles. And if this is kind of a big one too, on initial startup, if you're dealing with a unit that's really cold and you're installing it in a really cold system, or it's been off for a period of time, you want to energize your crankcase heater to get all that liquid pulled off your compressor. The inverter units, they won't even turn on until your crankcase has reached a certain temperature. So it's got that built into it. And on startup, airflow is important. Static pressure, taking a static pressure readings will kind of tell you where you're at. Air noise will tell you where you're at. The new heat pump systems, they used to say, 400, 450 CFM per ton. Each ton of cooling requires between, and it can actually be lower than that even, 375 up to 450 CFM per minute. So depending on what your system is, two-stage, single-stage, inverter, that all varies dramatically. So your duct design and construction, if you're laying it out, should be carefully done. System performance can be lowered dramatically through bad planning or workmanship. We've all seen those systems out there, just butcher jobs. Doesn't matter how expensive the house is or how nice the system is, it's not going to work. So air supply diffusers should be selected and located carefully. They must be sized and positioned to deliver treated air along the perimeter of the space. If they are too small, they will become noisy. If they are not located properly, they will cause drafts. Return air grills must be properly sized to carry air back to the blower. If they are too small, they will cause a noise like a whistle or a hum. Some of the new houses I still see it today on the second floor, even the main floors. They'll stick the supply air vents right smack in the middle of the rooms. No supplies on the outer perimeters. And these are brand new custom homes. And they'll stick one massive return air, upstairs, and it's supposed to do the whole house. So that's not that's something to pay attention with if you're installing a system. kind of take some of that into consideration. There's also an easy way to figure out your airflow. If you're doing electric resistance heaters, you can take the volts to the unit times the amps of the element consumption times 3.413 divided by your sensible heat constant, there again 1.8, times your temperature rise. That will give you your CFM for electric. For gas, a little bit easier. You take your output capacity in BTUs, not your inputs, your output. Divide that by your sensible heat constant, 1.08, times your temperature rise. And that's something you can do quickly to determine your exact airflow. So we'll get into what I consider some of the most important, your evacuation and leak testing. Evacuation is one of the most important of the entire system procedure. A good pump, good oil, clean oil. Don't change it, at the beginning of the season and put your pump away. I used to change my oil. My oil as a service guy, depending on what I did, I would change it even 2 or 3 times a week. Fresh oil will increase your vacuum and also speed up your vacuum. So air and nitrogen in the system will cause high condensing temperatures and pressures. You can also see that on your gauges. They'll violently flutter, they'll vibrate. Moisture also chemically reacts with the refrigerant and oil to form corrosive hydrofluoric acid, and that attacks your motor windings and parts, causing breakdown. That doesn't happen on startup, doesn't happen 6 months, 2 years, 3 years. That'll happen, 4, 5, 6, 7 years later. It'll start eating your compressor up. But the best way to do a vacuum, there's different ways you can do it. You can buy the trees, you can buy the large hoses, however you want to do your vacuum setup. But it is best to do a triple evacuation, because with a good pump and good hoses, I suck it down to a 500 micron no time at all. It will hold there. But if you draw it down too fast, you still have moisture in the system. So it is best to do a triple evacuation. So start your vacuum pump, get it to about 5,000 microns, purge it with nitrogen, do it again, get your vacuum down to about 1,400 microns, purge again with nitrogen, and then draw it down below 500. Once you reach 500 or below, turn your system off, let it hold for at least 15 minutes. As long as it holds there and it doesn't keep climbing. If it keeps climbing, you have a leak, or you still have a lot of moisture in the system. But if you hold at 500 microns, your system is clean, it is dry. I got to the point where I started doing that on every service call years ago. It may take me an extra 15 minutes, 20 minutes, whatever, but I guarantee you don't have to go back to that system. If you rush through, you start getting callbacks. Every callback costs the company more, free labor, and then also you got, upset customers. So let me get over here. Charging, yes. We've got a charging chart here somewhere. Yes. So this is the charging chart. I picked this one as a 14 SEER heat pump. Now this is really important. Excuse me. We'll just take a 2-ton here, your 1424 and your 1424. Just below that, you'll see, right here, you'll see a UF and an LF. You'll see a DF and an RF. So it's important to know what your orientation of the air handler is. Is it an upflow or a left flow horizontal, or is it a downflow and a right flow horizontal? So if we come down here we'll pick a 35-degree day here. So we have an upflow unit at 35 degrees, our gross pressures are 293 and 80. If it's a downflow unit, our gross pressures are 332 and 81. That's quite a big difference there on your head pressure. Now, our head pressures aren't the gospel. That's just a gross pressure, a good starting point. So we're going to go down here to our 35 degrees and find out our exact subcooling. So as an upflow, we're at 17 degrees subcooling, and as a downflow, we're at 35 degrees subcooling. So it's real easy to, with short line sets, to overcharge a downflow unit, especially in heating. So it's important to know what your orientation is, and then get your gross pressures, and then dial it into your subcooling. Some units, like air conditioners, will say all coils. In that case there's really no difference. But when you're dealing with heat pumps, it's important to know exactly what's your tonnage and your orientation. And then also, if you're going to do a two-stage model, a 16, any two-stage unit, you have to make sure you are in the second stage when you're testing it. And they tell you to run for at least 15 minutes. If you're doing a two-stage unit, I would say no less than 30 minutes, to give it plenty of time to stabilize. If you charge it in low stage, it's going to be wildly incorrect on second stage. Excuse me. If you start making adjustments too quickly on second stage, it's going to be wildly incorrect as well. So always reference the charging chart attached to the heat pump electrical panel. Find the indoor coil or air handler and orientation that you're working with. Find the intersecting point between the indoor coil and the outdoor temperature. Approximate any difference in the air temperature if it doesn't fall directly in line. So as far as your hookup goes, this is going to be your subcooling hookup for both cooling and heating. Always operate the heat pump in stage 2. Measure the system pressures. Add or recover refrigerant charge until the pressures are at or within tolerance of the charging chart. Like I say again, don't hold the gross pressures to be the gospel or the exact. What you're wanting to do is charge it directly to your subcooling. So you're going to have your high side gauge hooked up to your liquid line and use your pipe clamp to check your subcooling. Oops. So measure the liquid line pressure, convert the liquid line to saturation. Subtract the measured liquid line temperature from the saturation temperature. The difference is your liquid subcooling. Compare the measured subcooling against the charging chart. To raise the subcooling level, you add a small amount of refrigerant. Allow the system to run for a few minutes, 15 minutes. Recheck the liquid subcooling level. If your subcooling is out of sight, too high, you want to recover refrigerant and then allow the system to operate and stabilize before you recheck it again. If you jump the gun and start adding or subtracting too much, and I've done it before myself, you'll end up wildly off base. Charging in cooling mode should be done around minimum 55 degrees, preferably above that. Once your system pressures are within tolerance, and you make your final adjustment to the liquid subcooling, the system must have the following present conditions before attempting to charge. You have to make sure your air volume is in range, indoor air temperature. Well, they're saying 80 degrees, but rarely will we be at 80 degrees. The indoor and outdoor coils must be matched. Coils and return air filters should be clean, and line sets should be within allowable specs. Anytime you're going to charge a unit, service call, especially a service call, startup, you're typically clean. Um, check that indoor coil, check that indoor filter, check the outdoor coil. If any one of those are dirty, it's going to completely skew whatever your charge is. And you can make it look pretty good sometimes um, by, too much refrigerant or not enough refrigerant. Um, but it's important to notice those. So once you finish your installation on a service call as well, disconnect your pressure gauges from your ports. I'll usually take my finger, make sure I'm not hissing out anything of the Schrader ports. Put your caps on. You don't need to over tighten them. Replace the service valve caps. Make sure they're tightened as well. Replace your cover box panel. Always put your service caps back on. Guys leave those off and it just looks bad. And if you do have a leak, they're going to blame it on you for leaving the caps off. Always configure the indoor thermostat per customer's instructions. As a rule, installation or service, if we're running the unit, I want to turn it off, allow it to cycle off, and then turn it back on. So I know that it's shutting off as it should before I leave, and then I also know it's kicking back on before I leave. So that way you don't get the call back that, it's not working now. Okay, so we're it's almost 6 tonight. So does anybody have any questions this evening? Okay. Do take my number and my email down. If you have any questions anytime, feel free to give me a call, send me an email. I'm happy to assist you any way I can. Do appreciate you taking the time to watch the video tonight with us. So if we can be of any assistance, please let us know. And y'all have a good night. Thank you.